Things going well at home and that you're keeping up with your studies there so that you can move on to the 6th grade next year. Remember, we still have to learn all this 5th grade material in order to move on, so keep working hard at home, keep trying your best, give yourself a couple hours at least every day to work on your schoolwork for me and Mrs. Means, and there's also some stuff for Mr. Barta and Mrs. Brush and Mrs. Johnston as well, so keep your eyes open for that as well. Last week we learned about triangles, quadrilaterals, and three-dimensional figures. So what I want to do is on these 3 videos kind of go back over them because some of us had a couple of misunderstandings on a few things. So I want to try to clear those up in these videos, and then you're going to work on Think Central a little bit to practice more with triangles, quadrilaterals, and three-dimensional figures. Okay. Later this week too, you guys will be able to redo your red dots like we normally do in the classroom, but that won't be until Thursday. Okay, so it's really important that you go to Go Formative and you look at all of your homework from last week, triangles, quadrilaterals, and 3D figures, and see the comments that I made on every single one of them. Okay, make sure to read those because then on Thursday when I reset it, the comments are going to go away. Okay, so it's very important that you read those before Thursday. Okay, so triangles. There's 6 types of triangles. Okay, 3 types are named after their sides. 3 types are named after the angles. And that video last week kind of went through that as well. Okay, the first type is called an equilateral triangle. Now, if you look at the word equilateral, you see it looks almost like equal. And what equilateral triangles mean is that all 3 sides are the same length. Now in geometry we use these little tick marks, and if they have the same tick mark that means they're the same length. Okay, so all 3 would be equal. They're the same length. Also in an equilateral triangle, the angles are always going to be equal as well. Now if you guys remember, all 3 add up to 180 degrees. Okay, in a triangle it always does. So if I divided that by 3, because I have 3 equal angles, that means each angle is always going to be 60 degrees in an equilateral triangle. Okay, so once again, equilateral means equal. The next one is called an isosceles triangle. Okay, now isosceles triangles have 2 sides the same length. So if you look at this triangle on your screen, those 2 with the single tick marks are the same length. This one's different, so it'll get a double tick mark. Okay, so that's what they do to show that that one's different than the other 2. This is called an isosceles triangle. Now the way I remember it is the letter I. Okay, letter I. You have 2 eyes on your face, so an isosceles triangle has 2 equal sides. 2 eyes, 2 equal sides. Okay, that's the isosceles triangle. And then the third one based on its side is called a scalene triangle. In a scalene triangle, all the sides are different. So I'm going to have different tick marks on each side here. This one would have 3 then. In a scalene triangle, no sides are the same length. They're all different, okay? And the way I remember this one is the word scale is in there, okay? And before you step on a scale to measure your weight, it always reads 0, okay? So 0 sides the same length. So you see scalene, scale, has no sides the same length. So let's back up and look at those again. Equilateral, equal. Everything's equal about an equilateral triangle. The next one, isosceles. You have 2 eyes on your face, so there's 2 sides the same length. And scalene. Before you step on a scale, it reads 0, so that means there's 0 sides the same length. Alright, now they have 3 based on the angles. So we have a right angle, and you guys know that that's 90 degrees exactly. It's a perfect square corner. Then you have acute angles, which are smaller than 90, so it could be 89 degrees all the way down. Obtuse angles, they're more than 90 degrees, so it could be 91 degrees and all the way up. Okay, so those are important to know on this next part. So the first one we're going to look at is an acute triangle. Now this might look familiar. It looks a lot like the equilateral one we did, but it's also called an acute triangle because all 3 angles all three of them, are smaller than a 90-degree right angle. Okay? If all of them are under 90 degrees, and it has to be all of them, then it is called an acute triangle. Okay? But all three, once again, has to be smaller than 90 degrees. The next one is called a right triangle. Now, a right triangle will have only one right angle in the triangle. There's no way you can make a right triangle with two right angles. It just wouldn't work for two reasons. Number one, you couldn't draw another line. It'd be four sides instead of three. And if you remember, when we add up at 180 degrees, 90 and 90 is already 180 degrees. So you couldn't have that third angle. Okay? So a right triangle always has one right angle. Now some of you might say, but wait a minute, these two are acute, so isn't it an acute triangle too? No. Remember, acute triangles, all of them have to be acute. This one has a right angle, so this is called a right triangle. Okay? So if it's going to be acute, all of them have to be acute. If you see a right angle, it's a right triangle. And then the last one is called an obtuse triangle. Okay, and you'll look at this angle right here. That one's way bigger than 90 degrees. Okay, that's called an obtuse angle. So this is automatically an obtuse triangle. Now once again, like the right triangle, you might look at those and say, wait a minute, those are acute angles. So isn't this acute as well? No. Acute has to have all three of them acute. And since we have an obtuse angle here, it's automatically an obtuse triangle. Now I put together a couple practice ones for us so that we can see what the two names for these triangles are. Here's the first one. Okay, the sides are labeled and the angles are labeled. See if you can figure out which two names for this triangle would be. Okay, looking at the sides first, all three of them are different lengths. So that's called a scalene triangle. And if you look at the angles, all three angles are less than 90 degrees. So if all three are, that's called an acute. So this is an acute scalene triangle. Okay, how about this guy? There's two names always for triangles. So which two names would go with this one? Okay, so all of them, you see all the tick marks are the same. So that means they're the same length. So this is equilateral. And all three angles are less than 90 degrees, so that would also be acute. In fact, you learned earlier that in an equilateral triangle, they're always 60 degrees. 60 plus 60 plus 60 is 180. Okay, so this is an acute equilateral triangle. How about this one? Okay, I see two tick marks here, but that one doesn't have one. So that means these two are the same. That's an isosceles triangle. Remember, two eyes? And looking at these, they all look smaller than 90 degrees, so that one would be acute. This is an acute isosceles triangle. Okay, now sometimes they don't have the actual triangle drawn. They might just give you the lengths of the sides and the measures of the angles. Well, you can still figure out what the two names are just looking at the numbers here. So I'll give you a few seconds. What are the two names for this triangle? Okay, if you look at the sides, it looks like there's two of them that are 3.5 centimeters or 3 5/10 centimeters. This one's different. So that would be an isosceles triangle. Okay, now let's look at the angles. 27, 126, and 27 degrees. Well, this one's over 90 degrees. So if it's over 90 degrees, it's automatically obtuse. So this is an obtuse isosceles triangle. Okay, so now we learned about triangles. What I would like you to do is go to Think Central, log in, and work on the triangles. I think it's Chapter 11, Lesson 2. Work on triangles, and just like we do in class, you don't have to do the red dot. Just work through them and get triangles figured out.